Hello everyone, welcome to yet another demonstration video for the course Signals and Systems. As we have studied in module 2 about the eigenfunction property of the LTI system, we know that when a sinusoid input is sent into an LTI system, the output is again a sinusoid but with a different frequency and phase. So we are going to practically observe this today.
Here is the schematic diagram that we are going to use today. It's a simple RC circuit and the output is the voltage observed across the capacitor. As you can see, the output and the input can be related by this equation. We know that the ratio of output voltage to the input voltage is called the transfer function. Here we represent it by h of omega. H of omega can be given by 1 upon 1 plus j RC omega, which can be further simplified into this equation. Hence, the modulus of h of omega is given by 1 upon under root 1 plus RC omega whole square, and the phase of h of omega is given by this equation, which is minus tan inverse RC omega. So here is our apparatus. It is a simple RC circuit consisting of a resistor of 1 kilo ohms and a capacitor of 1 microfarads. From here we give the input to the RC circuit, and through these probes we fetch the output on the digital oscilloscope. As we have a resistor of 1 kilo ohms and a capacitor of 1 microfarads, the transfer function equations can be simplified as follows. The transfer function h of omega can be written as 1 upon 1 plus j 10 to the power minus 3 omega, which can be further simplified as 1 minus j 10 to the power minus 3 omega whole upon 1 plus 10 to the power minus 6 omega square. And the modulus of h of omega can be written as 1 upon under root 1 plus 10 to the power minus 3 omega whole square. And the argument of h of omega can be written as minus tan inverse 10 to the power minus 3 omega radians. First, we are going to assign a sinusoid of frequency 500 Hz as an input to the RC circuit. Therefore, the angular frequency omega 1 is equal to 1000 pi radians per second or 3141.59 radians per second roughly. Therefore, the transfer function h of omega is equal to 1 upon 1 plus j pi, and the modulus of the transfer function is equal to 0.303. The argument of the transfer function is equal to minus 1.2627 radians. Here on the oscilloscope, you can see the waveform with the larger amplitude is the input and the waveform with the smaller amplitude is the output. The ratio of the amplitude of the output waveform to the amplitude of the input waveform is 0.3. We have to find the time difference between the peaks of the output waveform and the input waveform and multiply it with the angular frequency. In this case, it is 1000 pi radians per second. Now, for angular frequency 1000 pi radians per second, we have calculated the amplitude of the transfer function to be 0.303 and the argument of the transfer function to be minus 1.2627 radians. From the practical observations, we have seen the amplitude of the transfer function turns out to be 0.3 roughly, and the argument of the transfer function is minus 1.162 radians. Now, for the sinusoid of frequency 2000 Hz or 2 kilohertz, we can find the angular frequency omega 2 to be 4000 pi radians per second or 12,566.37 radians per second roughly. Through this, we can find the amplitude of the transfer function to be 0.079 and the argument of the transfer function to be minus 1.4941 radians. Now on the oscilloscope you can see that The wave with the larger amplitude is the input and the wave with the smaller amplitude is the output. We can see that the ratio of the amplitude of the output wave to the input wave. Here on the oscilloscope we see the wave with the larger amplitude is the input and the wave with the smaller amplitude is the output. Through the practical observations, we find that the amplitude of the transfer function is equal to 0.081 and the argument of the transfer function is equal to minus 1.3823 radians. We have previously calculated the values for the amplitude and the argument for the transfer functions. The amplitude comes out to be 0.079 and the argument comes out to be minus 1.4941 radians.
This is Jatin Darsham signing off from the demonstration video. We'll be seeing each other again very soon. Thank you.